Here we're going to find the area of the region bounded above by the curve y equals x squared plus 2 and bounded below by the curve y equals negative x. So we might call the upper curve y sub 1 equals x squared plus 2 and the lower curve y sub 2 equals negative x. And bounded on the sides by x equals 0 and x equals 1. Okay, so since y sub 1 is the upper graph and y sub 2 is the lower graph, we have the formula a equals the integral from the lower x value a to the upper x value b of the upper minus the lower function dx. So that implies a equals, let's see, this 0 is our lower bound, and 1 is our b value, our upper bound. So our integral is from a to b, 0 to 1, of the upper function x squared plus 2 minus the lower function, minus x. There's no y's here. Everything is x, dx. So that's equal to 0 to 1 of, simplify, you get x squared plus x plus 2 dx. Take the antiderivative, you get x cubed over 3 plus x squared over 2 plus 2x. Evaluate that from x equals 0 to x equal 1. Now I pull out the LCD from the bracket. You don't have to. It's 1/6. So 1 over 6 times what's left is 2x cubed plus 3x squared plus 12x. Evaluated from x equals 0 to 1. So that's 1/6 times the evaluation of the antiderivative at x equals 1, minus the evaluation at the lower limit, x equals 0. Simplify, we get 1/6 times 2 plus 3 plus 12 minus 0, which is 17 times 1/6 is 17/6. That's the area between those two curves. Now, it would be actually instructive to see what this looks like. If we graphed it, we would see the line y sub 2 is y sub 2 equals negative x, and y sub 1 is the parabola that shifted 2 units up, x squared plus 2. And then the limits was x equals 0 to x equal 1. And then we have this entire area between these two curves from x equals 0 to x equals 1, even going down below the x-axis, because it's between these two curves, y sub 1 and y sub 2. So that's our area, 17/6 square units. Very nice.